Hello and welcome to today's webinar. My name is Finn Timmermann and I am here in the Harting Forum. Joining are my colleagues Dr. Mareike Lauf and Malte Hofmann. Today we want to talk to you about high-speed data solutions within the Han-Modular portfolio. I want to quickly go over the agenda for today. So first of all, I have the pleasure to introduce to you the newest addition to our Han-Modular portfolio, the Han Gigabit Cat8 module. Afterwards, my colleague Malte, who is our market specialist for the market segment railway, will be taking over and give us an insight on the data transmission and how it's handled in the railway market. Then I will take you to our samples and show you the solutions that we already offer within the shielded portfolio of Han-Modular. And afterwards, Mareike will be taking over and show our lab in general, and also we will be taking a look at the tests that we have performed to qualify our new Cat8 module. In the end of this session, we will be having some time to answer questions, so please don't hesitate to implement questions into the chat. We will be trying to answer them all. If not all questions have been answered, then of course afterwards we will be taking care of that and routing this to the specialists and answer them afterwards. So, as I said, my first point is the introduction of the Gigabit Cat8 module. And there, first of all, I want to give you an impression of the customer benefits, or of your benefits, that we have generated within this module. So, on the very top of our list, it was our goal to make the assembly easier for you. We have done so by creating a new isolation body, which has new elements and makes the assembly easier overall. In detail, we have created singular contact carriers, so you have the possibility to really have a good overview when assembling those new modules. And also we have modified some contours to make sure that we will reach the according categories like Cat6 and Cat8. In addition, it was our goal to implement our standard D-sub contacts. If you are familiar with our portfolio already, then you know that we already had a Cat7 gigabit module. In this existing Cat7 module, you had to use special contacts. And these special contacts naturally have another cost structure than our standard contacts. So using the standard contacts within this new module gives you a great potential for saving costs when using this new solution. Of course, we also had to make sure that we will reach the according categories. So we took a look at the changes that we have done within the module. And also during the development, we used our simulation department within our lab to take a look at the modifications that we have done. And afterwards, we could see immediately the effects of these modifications and knew that when we actually built the parts, that we were going into the right direction and that we would fulfill the specification Cat7a and Cat8. The last point I want to talk to you about in terms of benefits is going into the direction of maintenance. So if, for example, the module has to be maintenance, then you have the possibility to take a look at the contact positioning from the mating phase. So we molded the contact positioning into the mating phase to make it way easier for you to identify which contact is responsible for which transmission. Also, we have implemented little windows into the isolation body. This will be shown on the next slide. And within those windows, you have the possibility to identify the twisted pairs even after the isolation body is assembled. So overall, I think we have created some nice values for you also, and of course, the fact that we have reached the new category 8 is something that we are really proud of, and we hope that this is something that you can use also in the future, of course. So now I want to take the chance and take a little bit of a more detailed look into the inside of the module. So here on this slide, you see the Han gigabit module, and the lighter part on the inside is the isolation body. So we have created more space to bring the shielding of the twisted pairs directly to the rear of the contacts. This is quite essential to reach the according categories because there are many influences that can influence reaching those categories, and one of the facts is that you have to take the shielding of the twisted pair as close to the contact as possible. This was quite challenging in the existing product, so we took this chance of the new development to give you more space to bring the shielding directly to the contacts. As I said, we also improved the contours because even light spaces or light modifications can have a great impact on reaching Cat 7 and Cat 8. So as I said, we simulated those modifications, and at the end, we made the according modifications to reach these categories. In the last step, I want to show you the inside of the isolation body. So here on the right, we see our new contact carriers. And as I mentioned in the beginning, these contact carriers can be handled separately. So those 4 red parts you see there are separate parts. And you can take care of the twisted pair, of the assembly of the twisted pair separately. And when you have assembled all twisted pairs and are done with that, then you can implement them into the isolation body and put the lid on the whole isolation body and implement it into the module. So now I want to talk to you quickly about the different transmission classes that can be reached. So we have talked about Cat 7 and Cat 8 quite a bit, and if you are familiar with those transmission classes, then the more familiar ones are Cat 5 and Cat 6. I quickly want to point out some differences between those classes. The main difference lays within the frequencies of the classes that can be reached. So, for example, in Cat 5, we can reach up to 100 megahertz. And if you compare this with Cat 8, then we can reach up to 2000 megahertz. In Cat 6, we are limited to 500, and in Cat 7, we are limited to 1000 megahertz. In the new category that we reached in Cat 8, we are at 2000 megahertz and can transmit up to 40 gigabit. So this is quite a big step ahead, and brings a lot of security in terms of data transmission. The other point that I want to talk to you about is the distance that can be realized with the different categories. So the category 5, 6, and 7 can build up channels up to 100 meters. The difference lays in the category 8. The category 8 can build channels up to 30 meters. And there's another point that is noticeable. The 100-meter channels, meaning Cat 5, 6, and 7, can implement 4 connectors. And the channel of Cat 8, which is only 30 meters long, can only implement 2 connectors. So in the first 3 categories, you can have 4 connections, and in the category 8 channel, you can have 2 connections. So this is something that you have to keep in mind when building up your shielded connection that if you want to reach cut 8, then the number of connectors is limited within that channel. The use of the different categories reaches from private networks, like for example at home, often cut 5 is used. Then if we are going up to cut 6 and 7, then it differs somewhere between private use and professional use. But if we take a look at cut 8, status today is that it is only used in a professional field. And this will probably be the case for quite a while. So I hope I could give you an impression of our new module and also give you a little idea of the different categories so that when we talk about them, we have a common understanding. And now I want to hand over to my colleague Malte, as I said in the introduction, and he will give us a little insight on the transportation market.
Perfect. Thank you very much, Finn, for this introduction. Yes, Harting's production strategy is focused on a long-term availability to support the long service life of railroads. This means that installation-compatible products are still available for maintenance and repair works years later. Another important requirement is that the products should be as easy as possible to assemble, which we have seen from Finn with the new module here in this case. While at the same time, the process reliability must be ensured. Ideally, the products should also be future-proofed. What do we mean by this? For Harting, future availability is, for example, that modular designs for our connectors means that it always be possible to replace contact inserts so that the interface can meet the new requirements if necessary. Increasing bandwidths are also required by the railways, for example, to integrate sensors for optimized maintenance intervals, so-called predictive maintenance, or for greater passengers' comfort for information and entertainment systems. And of course, Wi-Fi access, which is very often used and even requested by passengers in trains in these days. As a fitting examples to today's topics, we have in our portfolio the so-called Han-Quintax or Han-Megabit modules, which are to be assigned to category 5. You heard from Finn, 100 megahertz is the maximum what can be reached. So this can be exchanged for the gigabit Cat 6, for example, our Han gigabit module Cat 6, or the new ones Cat 7a or even 8.2. In case of increased bandwidth requirements without this exchange having any effect to the other modules, like for power or signals. So anything what you have created in your connector in the past, you don't have to replace, you just replace the one module, in this case, for Ethernet. Therefore, the existing hoods and housings can also be continued to be used unchanged, which is, of course, a huge advantage in pricing and in timing, installation times. These models for the transmission of Ethernet are used for the backbone installation through the entire train, so really from the front to the end. And because it's so robust, it can be also used in particular in between the wagons, like the intercar vehicle coupling systems, or called jumper cables. Harting recommends and also offers by ourselves, so you can order this by from Harting, protective conduit solutions for jumper cables. Why? This is because changing modules naturally only works if the corresponding cable is also used. See, category 5 needs only 4 wires, category 6, 7, and 8 needs 8 wires. With this protective conduit solutions, the corresponding cables can simply be replaced without the need of costly and time-consumption replacements for the entire systems. Like to see, you can leave everything in between, just pull out the old cable and pull in the new one. Shielding concepts are handled differently by our customers, depending on their projects. My colleague will now explain in detail which options Harting offers to you. Finn, which variants the customers can take from Harting.
Yeah. Thank you very much, Malte, for the insight into the railway market and how our shielded modules are used within this market segment. I want to use the chance now to show you some solutions that we already offer, because of course the Cat8 module is not the first module that we have created to make a shielded connection within our connectors. So I want to structure this introduction by the principle of shielding, basically. And I would like to start out with a, let's say, simple version of shielding. So we have our shielded basic and shielded basic light module. The difference here is, I hope you can see this in the camera, that the shielded basic module has a 360-degree shielding, meaning that we have a metal cage that is around the isolation body, and the shielding can be attached right here at this little element at the end with an according zip tie. The zip tie will be also delivered from us because it's a special zip tie that can withstand the temperatures that are qualified within our connectors. So coming to the next module, the shielded basic light module, there we see that it is not implemented into a 360 metal cage anymore, but here we have a metal sheet that makes the connection within the industrial connector, and this metal sheet is responsible for bringing the shielding from the male to the female module. So also here we have the principle of attaching the shielding to the metal element in the rear, also with a zip tie. And since we are at that shielding principle, the last module that I want to introduce to you with this shielding principle is our shielded power module. The shielded power module was created to be implemented between a frequency converter and a drive. So we have created this module especially for this application, and also the number of pins, meaning we have 4 power pins and 2 signal pins, is also very specific for this usage. So that is the first shielding principle that we offer, and now I want to show you another module that we also have in our portfolio. This is the Han-M12 module. So here you have the opportunity to transmit 2 Ethernet connections within one single module. So here we have the 2 M12 elements, and those are implemented into one single module. The more sophisticated way to transmit the shielding within a connector are our metal modules, and these start with the megabit module that we see here. So we see our zinc die-cast body here, where the isolation body is implemented, and we have different modules for different categories. So the megabit module can be used for the category 5, and then we have the gigabit module, which can be used for category 6, category 7, and now also reach category 8. The principle of shielding with the metal modules are as follows. So we have those cable clamps in the rear of the module. Those will be attached to the cable, and the shielding, or the shielding is connected to this metal clamp. Afterwards, the metal clamp will be implemented into this area right here, and there we make a secure transmission of the shielding, and the shielding will be transmitted between the gigabit modules with small springs on the inside of the mating phase. So it is a secure data transmission and can be connected easily. Here I have an example of one of our industrial connectors built up with our Han-Modular portfolio. Naturally, since we want to show the shielded solutions in this area, the connector is built up with only shielded solutions or shielded modules. Therefore, I also brought another sample. So here we have our Han HBR compact housing, which is commonly used in the railway market that Malte just introduced. And here I have built up an example of a setup, for example, power and our new gigabit Cat8 module. So this would be a prototypical setup for a connector within the railway market. Finishing the introduction of our shielded solutions, I want to show you a module that we have launched not too long ago. So here we had the goal to bring the shielding from the module to the PCB. So we have created a PCB adapter that can be soldered directly to the printed circuit board, and then without much effort you can just attach the pre-assembled module, meaning this module doesn't have to be assembled because it's only combinable with this adapter, and you will get this completely pre-assembled. You just have to solder on the adapter, and also the shielding will be transmitted to the PCB. So this is a very new solution from us and is also available already. So the shielding itself has two principles within the portfolio. The one principle would be that we have a spring on the outside of the zinc die-cast body, which brings you into the position that if you implement this module into the hinged frame, then the spring will be connecting to the metal hinged frame. Meaning, if we implement this into a housing, your shielding potential will also be on the PE potential. The shielding principles are handled differently within our group of customers. So we offer both variants. You can order the module with the shielding spring, bringing your shielding potential to PE, or you can order the gigabit module or megabit module or shielded module without the spring. So you have the shielding, taken away from PE or being singular transmitted within the connector. So I think I have hopefully shown all the solutions that we offer already. And now I want to hand over to my colleague Mareike, who will be introducing our lab and, as I said, also some insights on the tests that we have performed.
Thank you, Finn. I'm Mareike Lauf, and I'm a test engineer at the Harting CTS, the Corporate Technology Services. I've been working there for over 10 years as a test engineer for electrical products. The CTS is situated at the HQT, the Harting Quality and Technology Center, which was purposefully built in 2014 just for our lab. In this facility, we work with 50 employees on over 5,000 square meters for 2,000 test reports per year. We are externally accredited by the DAX and the UL as well, and we do mostly electrical, mechanical, and environmental tests, but we also have the special fields with EMC, signal integrity, and fiber optical measurements for our fiber optical components. We also provide 1, 2, and 3D measurement equipment for the geometrical measurement of our products. Now, we have a huge variety in products at the for the Harting Technology Group, and of course, this is mirrored in the test equipment of our test lab. I would now give you a small insight into what we can do there. First of all, I want to start with a video from the tests that are the main issue here, so the signal integrity test. Signal integrity describes the quality of the signal that will be transmitted by the connector. So the signal is described with a rectangular shape and also its intensity. And different characteristics are now measured and tested, such as the transfer impedance, the characteristic impedance, but also the signal loss and return loss. And we have a very special expertise in these tests and also in the setup of this test, because it is very important that you have a good test set up to get reliable and reproducible results. So we make our own test adapters to create the very best test environment for these tests. I would now like to also present you with a few results from these tests. First of all, we start from the outside and we take the transfer impedance. The transfer impedance describes the shielding efficiency of the shielding housing, of the shielding enclosure of the connector. We see here in the diagram in red the limit values for Cat 6 or up to Cat 8 applications, and we see in blue the performance of the Cat 8 module that you've seen before presented by Finn. And we see they are very well below the respective limit values, so they show a very good performance for this category, for these categories. Now, if we take a closer look at the cable, we have the crosstalk. So in the past, it could happen, for example, if you have telephone lines and they were lying too close together, that you can hear strange voices on the phone because the signals were interfering. To prevent this, we need to have a high attenuation there to prevent the crosstalk. This is measured with this setup. And again, we have the limit values in red, and we see that we are well below all the limit values for all the high categories as well with our Cat 8 module. If we take a look at the return and insertion loss, this is now more about the quality at the signal. So basically that at the end of every connection we get a good signal to differ between the signal 1 and 2. And here we see again our specialized setup with the test adapters that are especially developed and created by Harting. And here we see again the limit values in red, and we see that again we have a very good performance with the Cat 8 module for all the different applications. I would now love to show you more of our tests. I prepared a video with electrical measurements that are also a very important part of our tests to get an idea about the functionality of our connectors. So we test the inserts, we test the contacts, and we check, for example, the contact resistance and the insulation resistance. We check the dielectric strength via an impulse withstand voltage test and a voltage proof test to see if there are any breakdowns or flashovers. This is carried out in the initial state, and then after some kind of aging to see if the material will age, or, for example, during a damp heat test, the insulation material can absorb water from the humidity and the insulation resistance might decrease, or you will get a flashover. This can also happen, of course, with a mechanical failure if contacts are damaged. I would also show you now these kind of agings. What kind of agings do we have? I prepared a video with some climate agings that we normally carry out. For example, we have a heat stress test where we have heat chambers. The specimen can now be stored at the limit temperature or any ambient temperature that is required for the application. We have climate chambers that will now combine a heat and a cold exposure and also add another stress with the humidity. All of these chambers have an outlet on the side, so during the tests we can monitor our specimens, we can take measurements, and we can also add another stress, for example, an additional electrical load. What's also very interesting is the functionality of our products at the different limit temperatures. For example, if we have a plastic enclosure and this plastic material is very prone to get brittle in the influence of cold, we can make a functionality test like mating cycles or locking cycles at the cold temperature and see if the locking mechanism will fail or if it will pass, if something might break, for example. All of these different agings are carried out due either to or according either to customer standards or we have product or market standards. So this will now conclude the small excursion into our test facilities. And I will now give the presentation back to Finn, who will lead the question and answering session.
Yeah. Thank you very much, Mareike, for the insights into our lab. I think it is quite interesting to see that we put our products into quite a bit of stress during the type tests to make sure that we deliver high quality and, of course, also safe solutions for you. So now, as I said in the beginning, we have a little bit of time to answer some questions if you have implemented some in the chat. We also gave you the opportunity to ask questions during the phase of the registration for this webinar. So the first question that we have was implemented during the registration phase. And this question is regarding the cable clamps at the rear of the metal modules that I have just shown you. I will grab it real quick. Camera doesn't have to follow. So, as I said, the shielding mechanism is realized with these metal clamps in the rear of the metal modules. And those metal clamps, of course, have a range of cable diameters that can be implemented. And this range was asked what this range is, and it goes from 4 millimeters to 14 millimeters. These clamps are available in a screw version or in a clamp version or in a crimp version. And in the crimp version, we have a ferrule and a crimp element. And the module itself can be qualified for the according crimp flange, meaning if you are not certain which crimp flange to use, first of all, of course, you can contact our specialists in the local subsidiaries who will support you in this question. And second of all, if that is not clear which one to use, then of course we also offer to qualify the according solution for you. The next question that we have received during the registration is regarding a hybrid connector, and there a solution for a Profinet connection in combination with the power connection is asked for. The Profinet connection, of course, can be realized with very many different solutions within the Han-Modular portfolio. One of that, for example, would be the RJ45 module in the simplest version. Then, we can also use metallized modules to realize this and combine this with a power module, as I showed you on the samples, where I built up the connector for the transportation market. There we had a combination of data transmission and power. This is the way that we would realize it within the Han-Modular portfolio. Since we have other portfolios also, of course, there are different solutions that could be realized. Another one would be the Han-Brit portfolio within our 3A housings. There we have combined power contacts with RJ45 directly in one isolation body. So I hope that answers the question in that regard. And the next question I want to point out here, which also was asked to us by during the registration. How can I get design guidance for my products and to make my design and order the products accordingly? There are different ways to do so. So there is the traditional way of contacting our local subsidiaries in your countries and ask for support there. The colleagues will gladly do so. And also before the pandemic, but during the pandemic, we have improved our online solutions to build up your connector, meaning we have a configurator where you can just put the according requirements of your connector inside the filters, and then the configurator will give you an according solution. And afterwards, you will get a bill of materials or a bill of material for this exact connector that you have built up with the according part numbers. And then also the process of order is becoming way easier and can be done directly. Yeah, this, if I have another question that just came in here during the webinar. Can the pneumatic module support transportation of gas mixture? In this case, O2 is asked for. If yes, what is the guaranteed pressure? The preferred is 4 to 6 millimeters. Okay, so this is going into the direction of the general modular portfolio. There we offer pneumatic modules from 3 millimeters to up to 10 millimeters. The question is basically asking if also gases can be transmitted. We will have to take a close look at which gas should be transmitted. Generally, our pneumatic module is qualified for pressured air, and therefore there's always a risk of resistances in materials. And of course, we have to make sure that the gas that you transmit is not flammable because of the electricity within the connector and the sparks that can be created. We have to be very careful with that. So I think what would be the max internal cable diameter which your crimp flage can support? Yeah, that was the first question that I answered basically. It goes from 4 millimeters up to 14 millimeters. So that is the range that we can realize within the screw flange and also in the crimp flange. There's another addition to the question for the gases. Metal contacts and plastic tubes are preferred. The application is medical. Yes, so also for this requirement we have a solution. The plastic pneumatic contacts are already available for a very long time, and in 2017 we launched our metal pneumatic module, and there we have metal contacts, as I said, from a range from 3 millimeters up to 6 millimeters within a single module. And now we have launched in the middle of last year, we have launched the double module with bigger contacts and also bigger possibilities to attach the tubes, and those are 8 millimeters and 10 millimeters, which of course can be used within a medical application. So that was, I think, my last question. I hope I was able to answer them as you wished, and if not so, then please get in contact with us and we will try to answer them then. And now I want to make a little bit of advertisement because we are in the middle of our web series Han-Modular. My colleague Heinz Günther already made a webinar in March regarding the general setup of modular connectors and what you have to look for and what is possible. So today we talked about high-speed data transmission and the different principles of shielding within our connectors. And in the next month, in May, my colleague Heiko will also have a webinar and introduce a very, very new solution that we have created, and I think it is quite fascinating. So we put this in a little video, and please see for yourself. Thank you very much for your time and your attention, and I hope we will see us soon again here in the Harting Forum. Thanks again, and bye-bye.